We are taking R.D. Sharma Solutions, Class 10 Maths, Chapter 16, Exercise 16.2. So the first question is, there is a tent here and we have to find out the area of the canvas when there are two parts of this object, or you can say this tent. First is this conical one, and then we have this cylindrical one, this conical one and this cylindrical one. So what all are given is, let us take the things which are given is, this is radius of the cylinder part. This is the radius of the cylinder part, which is 12 meter. So this is the radius of the cylindrical part, and this is also the radius of the conical part. And the height of the conical part is given 5 meter, and the height of the cylindrical part is given as 11 meter. Now we have this as 5 and this one as 12. So in order to find out the curved surface area, we need to find out the slant height. So if this is 5, this is 12, what this will be? 12 square plus 5 square. So this is going to be 13. Okay, this is going to be 144 plus 25, and that is going to be under root of this 169, and then it is going to be 13. So L is 13. Now the curved surface area for the cone will be pi into r into L. Pi into r into L. So pi is pi, we know the value. R we are going to use as 12, and L, which is the slant height, is going to be 13. Now what is the curved surface area of this cylinder? This is going to be 2 pi RH. 2 pi RH. So 2 into pi into r, radius 12, and height is given as 11. So when you combine this, or when you add this, you are going to get 13 and 13, 20. And this is area of the canvas required for the tent, which is 1320 meters square. Now consider a rocket. So it's a rocket. Suppose the rocket is in the form of a circular cylinder. So this is a circular cylinder, and it is closed at the lower end, while the cone, this is a cone of the same radius attached to its top. So the cylindrical portion of the rocket has radius 2.5 meters. So this is 2.5 meter from here to here. So the cone will also have the radius as 2.5 meter. And the height of the cylindrical portion of rocket is 21 meters. So this height is 21 meter. And the conical portion of the rocket has a slant height. So this is a slant height. This height is given as 8 meter. So we have to calculate the total surface area of the rocket and also find the volume of the rocket. So total surface area and volume. So we have the radiuses, and then we need to find out the height also, because this height is important. Otherwise we will not be able to find out the volume. So because the slant height is given, we'll start with the total surface area. What is the surface area? This surface area of the cone, which is pi into r into L. Pi is 22 by 7, r is the 2.5, which is this one. Radius is, both of them have same. And then L is the slant height. It is 62.85. Now what is the surface area of the cylinder? Because this is covered by cone, so we don't take this one, but we'll take the curved surface area along with this base. So 2 pi RH and pi r square. So we have to add this. So radius is 2.5 and height is given as 21, and also the radius will take it as 2.5. So this is going to come as 349.64. Now in order to find out the total surface area of the whole object, we just have to add these two. So that means this one and this one has to be added. So this comes to be 412.69. So the total surface area of the cone is 412.69. Now the slant height of the cone, because let me take this triangle. This one is 8. This one is 2.5. So the height will be like this. So height of the cone will be 8 square minus 2.5 whole square. So 8 square minus 2.5 whole square, that will be 7.59. What is the volume of this cone? 1 by 3 pi r square h. R we know 2.5, height we just found out. So just multiply and 49.10 will come. And coming to the volume of the cylinder, it is pi r square h. Pi into r square into h. So pi, radius is 2.5 and height of this cylinder will be 21. Now these two have to be added. These two have to be added in order to find out the total volume of the rocket, and this is going to come as 461.6 meter cube. Take a tent structure is envisioned being cylindrical in shape with the height 77 decimeter and is being surmounted by a cone at the top having height 44 decimeter. The diameter of the cylinder is 36 meter. Find the curved surface area of the tent. So here what we will do, see, I'll just show you and then I'll come back to this one. Okay, now take a tent structure, cylindrical in shape, surmounted by a cone. So same thing is going on. This type. So now what is given? Height of the tent. Height of the tent is given as 77. So from here to here it is 77. Then height of the surmounted cone is 44. So this is 44. And what is this? What is this height? It is 77 minus 44. That is, this is going to be 33. Right? 77 minus 44 is 33. So now the height of the cylindrical portion we found out using 77 minus 34, that is 33 decimeter. And we know that in order to convert the decimeter into meter, we just have to divide it by 10. Right? So it will be this 3.3 decimeter, and this will be 4.4, this will be 7.7. Now, coming to the diameter of the cylinder, which is D, which is given here. The diameter of the cylinder is given, so the radius will be 36 by 2 and it will be 18. So it will be 36 by 2, that is 18. And what is the slant height of the cone? Because it is 18 and this is 4.4. Okay, this is 4.4 because this was the height of the cylindrical portion, so height of the cone. Okay, we have to find out. So this will be not 3.3 whole square, but it will be 4.4 whole square. Okay, this is 4.4. Height of the surmounted cone. So we are interested in the slant height of the cone. So 4.4 square will be there. And this L will come as 18.3. If you just let me show you the calculation. So this 18 square will be 18 into 18 is 324 plus, and then we have 4.4 into 4.4, and this is going to be 343.36. okay, and same thing, and just take the root of this one. When we take the root of this one, it is going to be 18.3. This is just 4.4. Now the slant height is also known. Coming to the curved surface area of the cylinder, it is going to be, cylinder will be 2 pi RH. We know 2 pi, we know the radius, and h height for the, see, height is this one for the cylinder. So it is going to be 3.3. Just a minute changes there. Then curved surface area of the cone is pi into r into L. Pi into r, 18 into L, we just found out 18.3. And you just need to, this is 3.3. This is 3.3, right? Cylinder. Now just add these, you'll get 1532.46 meter square total surface area. You have to add 2 pi RH with pi RH. A toy is in the form of a cone surmounted by a hemisphere. So this is a cone. This is a cone surmounted by a hemisphere. So the diameter of the base and the height of the cone are 6 cm and 4 cm. The diameter of this base and the height of the cone is 6 and 4 cm. Determine the surface area of the toy. So now we have this as 3 and this is 4. So what will be the slant height? This height, it will be 3 square plus 4 square under root for this conical part, and this is going to be 25, under root 25, and it is going to be 5. So this phi is the slant height. Phi is the slant height of this cone, right? Now we know that the curved surface area of the cone is pi into r into L. This one, pi into r into L. We just found out this to be 5, and radius we already know it is 3 for both of these toy objects or parts. Now curved surface area of the hemisphere. This hemisphere, actually the hemisphere has a curved surface area. Total surface area a hemisphere has is 4 pi r square. So a sphere, and a hemisphere will have 2 pi r square. So 2 pi, again 3 square. So it will come as 56.23. This will come as 47.1. So you just have to add these two, and this is going to be 103.62 centimeters square. This is the curved surface area of the toy. A solid is in the form of a right circular cylinder, if you see here, with a hemisphere. This is a hemisphere at the one end, and there is a cone at the other end. Hemisphere and cone at the other end. The radius of the common base is 3.5 meter. This is 3.5, this is 3.5. So the radius for all these three different parts of this, you can say toy or an object, these are all same. Radius is same for everything, every three parts here. So R is 3.5, and the height of the cylinder and the conical portion are 10 and 6. So height of the cylinder is this much, 10, and then 6 is the conical portion. So 6 is this one. And we have to find out the total surface area. So total surface area, let us start with the cone part. So this is 6 and this is 2.5. So 6 square plus 3.5, sorry, 3.5. So this is 3.5. So 6 square plus 3.5 whole square. If you take this triangle, this is 6 square, this is 3.5 whole square. This slant height will come and it will be under root. So it will be 6.94. And now the curved surface area of the cylindrical part. Cylindrical part is what? 2 pi RH. R we already know, height is already given 10. So 2 pi RH, it is going to come as 220. The curved surface area of the cone is pi RL. So L we just found out. Radius is same for each of these. So pi into 3.5 into 6.94, it will come as 76.34. Now coming to this hemisphere part, it will be 2 pi R square. The curved surface area. Radius is 3.5. So it is going to come as 77 centimeters square. So the total surface area of the solid will be this one, S1 plus S2 plus S3, and it is going to be 373.34 centimeters square. A toy is in the shape of a right circular cylinder with the hemisphere at one end and cone at the other end. So if I can show you the diagram, I have to make it. So let me make the diagram first, then we may be able to understand it better. A toy is in the shape of a right circular cylinder with a hemisphere on one end and cone on the other. So there is a cone, there is a cylinder, and this is three parts actually. So we have a cone, we have a hemisphere, and we have a right circular cylinder. And the radius and height of the cylindrical part are 5 and 13. So radius is 5, so 5 will be radius for each of these. And what is the height? It is 13. The radii of the hemispherical and conical parts, they are same because they are entirely fixed on it. Find the surface area of this if the total height of the toy is 30 centimeter. So total height is 30 centimeter. So this is 13. What is the radius here? This portion. And this is going to be the radius here. So it will be 5 also. This will be 5. So 5 is there, 13 is there. What will be the height of the cone? It will be 30 minus 15 minus 5. 30 minus 18 actually. It is going to be 12. So the height of the conical part is 12. Now coming to the curved surface area of the cylinder, it is going to be 2 pi RH. So 2 pi, radius is given, height is given. 2 pi RH, it is going to be 408.2. Now curved surface area of the cone, it will be pi into R into L. Pi into R into L. So what will be the L? This is 12 square, this is 12 and this is 5. We just found out. 12 and 5. So this will be 12 square plus 5 square whole square. This one, it is going to come as 13. So pi into 6 into L, L will be, say I just told you the height we found out to be 12. And then this L will be under root R square plus H square, that is 5 square plus 12 square, 25 plus 144, it is going to be 169 under root, it is going to be 13. So we just have to write here 13, pi into 5 into 13. Now curved surface area of the hemisphere is 2 pi R square. Radius is same for all these three, it will be 5 only. This will be 5, so it will be 2 pi R square. And now you have to add these three, S1 plus S2 plus S3. So this one and the previous one we found, we just have to add it. It is going to be 769.3 centimeters square. Consider a cylindrical tub having a radius of 5 centimeter and the length is 9.8 centimeter. It is full of water. The solid is in the form of a right circular cone mounted on a hemisphere which is immersed in this tub. If the radius of the hemisphere is 3.5 centimeter and the height of the cone outside the hemisphere is 5 centimeter, find the volume of water left in the tub. So we have a cylindrical tub here, like this. This is a cylindrical tub having a radius. So this radius is 5, length is given as 9.8. A solid is in the form of a right circular cone mounted on a hemisphere. So there is like this. So it is being immersed now in the water. And the radius of the hemisphere, this radius is 3.5. This is 3.5. And the height of the cone outside the hemisphere, which is this one, is 5. This is 5. Find the volume of the water left in the tub. So when this object or this is placed in this cylinder, the water will come out, and the water that will come out will be equal to the volume of the immersed or submerged this object of cone and hemisphere. So what we will do, we'll find out these two combined area, and then the cylinder area. Cylinder will have some water. So the cylinder water, when it is subtracted from this volume, which is the volume of this object, that will be the volume of the water being left. I hope you got the idea. We'll find out the volume of this one, and the combined one, we'll subtract that, then that will be the volume which is water, because this has gone inside, water has come out. So the water which has come out is actually equal to the volume of this one. So we just subtract this volume with this one. Now here various things are given. Let R be the radius and H be the height of the cylindrical tub. So R is 5 and H is 9.8. This is 5, this is 9.8. So volume is pi into this volume is pi into R into, this is cylindrical part, pi R square into H. So pi into 5 into 5 into 9.8, pi R square is 770. Now for the hemisphere it will be and cone. Hemisphere is 2 by 3 pi R cube. So we know the R 3.5, 2 by 3 pi R cube. And we know the volume of the cone, which is 1 by 3 pi R square H. R is 3.5, height is already given 5. So this is 64.16. So what we will do, we'll add these two and subtract the addition from here. So 770 minus 89.83 minus 64.16, and this is the volume of water which will be left in this cylinder, and this is going to come as 616 centimeter cube. Now a circus tent has a cylindrical shape surmounted by a conical roof. The radius of the cylindrical base is 20 centimeter. The height of the cylindrical and the conical portion is this much, 4.2 and 2.1. Find the volume of the circus tent. So here we have a circus tent, we have a conical shape, and this is a cylindrical shape like this. Now the radius of the cylindrical base is 20. So this is 20, this is also 20. And the height of the conical portion, cylindrical and conical portion, so cylindrical portion is 4.2 and conical portion is 2.1. This is 2.1 and this is 4.2. Find the volume of the circus tent. So the parameters given here are like this. Volume of the cylindrical portion will be pi R square H. So it will be pi R square H. And this we can compute because R we know 20, height is 4.2. So it is going to come as 5280. And what is the conical part? It will be 1 by 3 pi R square H. 1 by 3 pi into R, R will be 20 square, height will be 22.1. And this is going to be 880. So you just have to add these two to find out the volume of this circular tent. A petrol tank is a cylinder of base 21 and length is 18. This is 18. And this is fitted with conical ends. So this is one conical end, this is another conical end. Each of X is 9 centimeters. Each of them is having a height of 9 centimeters. Determine the capacity of the tank. So what we will do, we'll find out the volume of this one and these two and add them. Okay. So what all are given? See, this radius is because the diameter of the base is 21. Radius will be 21 by 2. So the radius will be 11.5. Radius of these two will be 11.5. And length is 18 centimeters, so length is 18 centimeters. And determine the capacity. So what is the volume of the conical part? It is going to be 1 by 3 pi R square H plus 1 by 3 pi R square H. Actually, it is 1 by 3 pi R square H into 2. So 1 by 3 pi and R is 11.5 and height is this part is 9. So 9. Okay, we just took one of these and multiplied this with 2. So this is going to be the volume of the conical part. When come to the cylindrical part, it will be pi R square H. So pi R is, this is 11.5 and height is this 18. So pi R square H, it is going to be 7481.57. And we just have to add these two and this is going to be 9975.41 centimeter cube. This is the total capacity in which we have a conical hole. We have a cylinder and there is a conical hole in this cylinder. The height is given as 12 centimeter and the base radius is 5 centimeters. So both of them will be having their base radius as 5 centimeter. The height and base radius of the cone are also same, that is given here. Find the whole surface and the volume of the remaining cylinder. That is, we'll try to find out the volume of the cylinder and subtract the volume of this cone, that will be the remaining cylinder. So here we have this as 5, the height is also given as 12. So we can find out the slant height of the cone. That is going to be 5 square plus 12 square under root. We are using the Pythagoras theorem. So L will be equal to under root 12 square plus 5 square under root 169. So the slant height would be 13 here. This will be slant height. Now what is the total surface area? Total surface area will be this one plus this one. Okay, this one plus this one. That is, what is the curved surface area of the cylinder? 2 pi r h. What is the base area of the cylinder? It is pi r square. And what is the curved surface area of the cone, which is actually the cut part of the cylinder? That is pi r l. So we just have to add these three. And we know the radius, now we know the slant height also. Just put in here, it will be 210 pi. Coming to the remaining part, we have to take the volume of the cylinder minus volume of the cone. Volume of the cylinder is what? Pi r square h. Volume of the cone will be 1 by 3 pi r square h. So pi you can take out, r is 5, h is 12. Here we have again r as 5 and h is 12 because they both share the same radius and height. It is going to come as 200 pi. A tent is in the form of a cylinder. We have a cylinder of diameter 20, so the radius will be 10. The height 2.5. This is 2.5 surmounted by a cone of equal this base, that is the radius will be same, and the height is now 7.5. So the height of the cylinder is 2.5, height of the cone is 7.5. Find the capacity of the tent and the cost of canvas as well as the price of rupees 100 per the square meter. So here what we will do, capacity we have to find out. So first of all, this is the height 7.5 and this is the base which is 10. So we have to find out the slant height. So 10 square plus 7.5 whole square under root. This is going to be the slant height of this cone. What is the surface area of the cone? Pi into r into L. So pi is there, r is the radius 10 and L, which is the slant height, which is going to be 12.5 from here. And this is the surface area of the cone. And what is the volume of the cone? It is 1 by 3 pi r square h. R is 10, h is 7.5. So this is going to be 250 pi. Coming to the surface area of the cylindrical part, it will be 2 pi r h. Radius is 10, height is 2.5. The volume of the cylinder will be pi r square h. Pi into 10 into 10 into height is 2.5. The total capacity will be this capacity 255 plus this capacity, which is going to be this 255. So it is going to be 500 pi. And what is the total area of the canvas required? It will be simply the addition of the surface area of the cone and the surface area of the cylindrical part. So we just add them, it is going to be 550 meters square. So the total cost of canvas will be what? This is the meter square. This is the total surface area. So for 1 square meter it is 100. So 1 meter square it is 100. So for the 550 it will be 550 into 100 and this is going to be 55,000. Consider a boiler. This is a boiler, is in the form of a cylinder. So we have a cylinder here having the length 2 meter and there is a hemispherical end, each of having diameter 2 meter. This is diameter 2, this is diameter 2, this is 2 meter again. What we have to find the volume of the boiler. So we have to take this part and these two parts are exactly similar. So this is 2 by 3 pi r cube. The volume will be for this one, that is the first and second part, is 2 by 3 pi r cube. So 2 by 3 pi r cube, 2 by 3 pi r cube, that is 4 by 3 pi r cube. And how about this cylindrical part? The cylindrical part is pi r square h. Pi and radius is what? See, this is the diameter is 2 from here to here. Radius will be 1. So radius for this one also will be 1 and this one will also be 1. So pi into r square into h. What is the height? The height for this one is 2 and height for this one is given as we don't need the height here. So this is going to be 220 by 21. This is the volume of the boiler. A vessel is a hollow cylinder. So this is a cylinder which is hollow, fitted with a hemispherical bottom of the same base. So this is the hemispherical bottom of the same base. The depth of the cylinder is 14 by 3. So from here to here it is 14 by 3. And the diameter of the hemisphere is 3.5. So diameter is 3.5. Just take it half. It will be 1.75. We have to calculate the volume and the internal surface area of the solid. So we'll take this part and this part, take the volume, add them. Also, the surface area of the hemisphere will take, and the surface area of the cylinder we are going to take. First of all, the radius, as I said, 3.5 by 2, because 3.5 is the diameter. It is going to be 1.75, and the height will be 14 by 3. So total volume will be the addition of the volume of these two. So this volume will be pi r square h. R will be 1.75. Height is 14 by 3. And for this hemisphere, it will be 2 by 3 pi r cube. So 2 by 3 pi r cube, our radius we are going to take as again 1.75. Just add them, it is going to be 56.06. When it comes to internal surface area of the solid, it will be surface area of the hemisphere plus the surface area of the cylinder. That is, surface area of this part, that is the hemisphere part, is 2 pi r square. Surface area of this cylinder will be 2 pi r h. So just add them, because we know the radius is 3.5 by 2, 1.75, and height of the cylinder is 14 by 3. It is going to be 77 by 12. The calculation is in front of you. Consider a solid which is composed of a cylinder. This is a cylinder part, and with hemispherical end. So this is first part, this is second part, and these are the hemispherical end. The complete length of the solid is 104 meter. From here to here it is 104 meter, and the radius of each of the hemispherical end is 7 meters. So this is the 7 meter radius, and this is the 7 meter radius. And find the cost of polishing its surface at the rate of 10 per decimeter square, or 10 per decimeter square. We are going to change it into centimeter or meter square. Okay. Now, first of all, this part, what will be the height of the cylinder? This is total 104. This is 90. How? Because this part is 7, so we subtract this 7 part, and this is also 7, so we subtract this also. So 104 minus 14 is going to be 90. So 90 is the height of this cylinder. And what is the total surface area? It will be 2 pi r h for the cylindrical part, and the hemispherical part, it will be 2 pi r square. This will also be 2 pi r square, so total will be 4 pi r square. Height is now 90 for the cylinder h, and radius is, of course, both has same, so 7. So we just computed 4, 5, 6, 7, and this is 10 per decimeter square. You just have to convert it into because this is centimeter. So this 10 per decimeter square, and we have to convert it into the centimeter. So divide it by 100 and multiply it. It will be 457.60. A cylindrical vessel of diameter 14 centimeter and height 42 centimeter. So we have a cylindrical vessel. Let me make a cylindrical vessel. Now here the diameter is 14, so the radius will be 7, and height is 42. So 42 is the height. Is fixed symmetrically inside a similar vessel of diameter 16 centimeter and height 42 centimeters. So the height remains the same, but now there is one more cylinder. So this cylinder is having the diameter of 16, so the radius will be 8. From here to here it will be 8. The total space between the two vessels from here to here, means this space we are talking about, is filled with a cork dust for heat insulation purposes. Find how many cubic centimeters of cork dust will be required. So we need to find the volume of this region, actually, outer region. So we'll take the volume of the outside, we'll take the volume of the inside, and just subtract it. So the volume of any of the cylinder will be pi r square h. So this will be pi r2 square. This capital R is the outer one. Pi r square h minus pi small r square h. It will be pi into h and r square minus small r square. So what is the radius? As I said, the first radius, the outer radius is 8, inner radius is 7. So just put in here pi. Height is 42, r2 square minus r1 square, that is 8 square minus 7 square. You compute it, it will be 1980 centimeter cube, right? A cylindrical road roller made up of iron 1 meter long. Its internal diameter is 54 centimeter, and the thickness of the iron sheet used in making the roller is 9 centimeter. find the mass of the rod roller if 1 centimeter cube of the iron has 7.8 gram mass. So here we have a rod roller. We assume it to be cylindrical size. Now the cylindrical rod roller made up of iron is this much meter long, so it is 1 meter long. And since others are in centimeter, we will convert it into the centimeters. 1 meter is 1 into 100, that is 1 meter is 100 centimeters, so it will be 100 centimeter. So this will be 100 centimeter height. Then internal diameter is 54, so the internal radius will be what? Internal radius will be 54 by 2, that is 27. And the thickness of the iron is 9. So this thickness is this iron from here to here, it is 9. So what will be the outside radius? 27 plus 9. So the small r, that is internal radius, is 27. The capital R, that is the outer radius, will be 27 plus 9, because 27 is the internal radius and 9 is the thickness. So 27 plus 9 is going to be 36. So internal radius and outer external radius, what we have to do, we have to take the difference of the volume, that is pi r square h, outer one minus pi r square h, internal one pi into h, r square minus small r square, this r square, this is 36 and this is 27. Height is 100 centimeter, pi is 3.14. This will be the volume. Now 1 centimeter cube, the volume is 7.8 gram. So for this much centimeter cube, you just have to multiply this and this. So multiply these two, and now this comes in gram. Just put some, take it here, point here, it will be in, or you can say you divide it by 100, 1000, so it will be in kg. So it will be 1388.7 kg, mass of the rod roller. A vessel is in the form of a hollow cylinder. So this is a hollow cylinder and mounted by a hollow hemisphere on a, this is a hollow hemisphere and this is a hollow cylinder. The diameter of the hemisphere is 14 centimeters. So this is 14 centimeter diameter. So the radius will be 7 and the radius of the cylinder will also be 7. And the total height of the vessel is 13. So here to here it is 13. And this one, this height or you can say radius of the hemispherical part is 7. So what will be this height from here to here? It will be 13 minus 7 and that is going to be 6. So this is 6 centimeter. So the inner surface area of the vessel will be what? It will be this surface area plus this surface area. Surface area of the hemisphere is 2 pi r square and surface area of this cylinder is 2 pi r h. And we know all the value. Radius is 7 for both and height is 6, we just found out. And it is going to be 572 centimeters square. A toy is in the form of a cone. So here is a cone we have, and there we have a hemisphere. So the toy is in the form of a cone of radius 3.5 centimeter mounted on a hemisphere of same radius. So the total height of the toy from here to here, it is 15.5 centimeter total height. The total surface area has to be found out. Now the total, this height is given as 15.5. This is the radius 3.5 and this is 3.5. So what will be the height here? 15.5 minus 3.5. So the height will be 15.5 minus 12.5. That is going to be 12 centimeter. This is the 12 centimeter height. Height of the cone. Okay. And radius of the cone and radius of the hemisphere will be same. Now we have to find out the total surface area of the toy. So it will be the curved surface area of the conical part and the surface area of this hemispherical part. And this, what is the because slant height is already given, so we don't have to find out the, this one, this L, it is already given as, okay. Now there is a change. I just need to change something here, because we need our L, and this L is nothing but the height we found out. So what we are going to do, this is 12 and this is 3.5. So we'll find out this one, that is the slant height. So it will be, this will be 12 square plus 3.5 whole square. So this will be 144. And what is 3.5 whole square? Let me compute. 3.5 into 3.5. And this is going to be 12.25. We just have to add them. That is, you have to add plus 144. And this is going to be 156.25. And 156.25, let me just find out the 156, the root. Okay. So I'll just take the root of 156.25. It is going to be 12.5. So now here, this is not 12, this is 12.5. There is the only difference. So the answer will come as, it will be 12 and 12.5 doesn't there's no huge difference. So this 12.5 can be added to this 7, it will be 19.5. So just I'll give you the exact answer now. Okay, so what we have to do here is, this is 3.14 into this 3.5, that is going to be 10.99 into 19.5 here. I hope you got the idea. So the answer will be 214.305. Okay, this is the answer, centimeter square. So the difference between outside and inside surface areas of cylindrical metal pipe 14 centimeter long is 44. So we have a cylindrical metal pipe, say like this, and there is an outer one and there is an internal one. So the difference between outside and inside surface areas, so surface area we have to find out. First of all, we know that the surface area of a cylinder is 2 pi RH. We'll take the difference. The height is given 14 is 44 decimeter square. That means 2 pi RH, let us take the capital R, that is the outside radius as capital R and inside radius as small r. So 2 pi RH, which is the outer, you can say outer curved surface area minus the inner curved surface area, is given as 44. Now 2 pi r take common, this r minus r is given by, just if you compute it, let me do it for you. So 2 pi RH, I am taking 2 pi h outside, that is 2 into 22 by 7. The height is given as 14, and then r minus r is equal to 44. This is 44, this is 7 to the 14. So r minus r is half, or you can say 0.5. Now coming to the second part, which is the pipe is made up of 99 centimeter square of metal. So this is now the difference of the volume. So volume of the outer one is pi r square h, capital as r square h, and the small r is the inside one, pi r square h. This is given as 99. Again, same thing we are going to do. We'll take the pi and h common. Let me just write the values into h. And this is r square minus r square. So this will be r minus r and r plus r. And this is going to be 99. Okay. So this r minus r is already half. So for this we can write half. So 2, 11, right? 11, 9. 11, 9. So what do you get? This r plus r is given by 9 by 2. This is 7 to the 14. So 2 goes here, 9 by 2. Now r plus r is known and r minus r is known. Just add them. So you get 2r equal to 9 by 2 plus 1 by 2, that is 10 by 2, that is 5. So r is, capital R is 5 by 2. Put it here, the small r will come as, just put it here, any of this. The small r will come as 2 centimeter. So the outer and inner radius is 5 by 2, that is 2.5, this one, and 2 centimeter, which we got it from here. A right circular cylinder having diameter 12 centimeters. So there is a right circular cylinder, and the diameter is given as 12 centimeters. So let me take the radius as 6. Height of 15 centimeters. Okay, is full of ice cream. The ice cream is to be filled in cones. The ice cream is to be filled in cones. This is a cone. The height is 15 centimeter and the diameter is again 6. This diameter is 6 centimeters. So the radius will be 3 centimeter. Diameter is 6 centimeter. So radius will be 3 centimeter. Having a hemispherical shape on the top. So here is a hemispherical shape. Find the number of such cones which can be filled with this ice cream. So the ice cream from here has to be transferred here. Suppose that you take out few of them and this number of ice creams are formed. So we have to take the volume of the cylinder. This is equal to n into volume of this cone. So n will be simply volume of cylinder by volume of cone, or cone object, because there is a hemisphere also. Now the radius of the cylinder is given as 6 because it's 12 by 2. The height is given as 15. So we can easily find out the volume of the cylinder, pi r square h. Pi into 6 square into h, which is 545. Coming to this one, the radius of the ice cream is 3. The height of the cone is 50. This height of the cone is 12. How this, the height of the cone is already given, 12, right? Then we have the volume of the conical part will be 1 by 3 pi r square. So 1 by 3 into pi into r square, 3 square into h, that is 12. Height is 12 and radius is of course 3. And volume of the conical, this part, hemispherical part. So just let me, this is the 1 by 3 pi r square h. This you can easily find out. Now coming to the hemispherical part, I am talking about this. It will be 2 by 3 pi r cube. 2 by 3 pi r cube. Radius is 3, so 2 by 3 pi r cube. Radius is 3, so it will be 18 pi. Now what is the volume of the ice cream? This part plus this part. So it will be 36 pi plus 18 pi, that is going to 54 pi. Now as I said that the number of this cone or cone shape ice cream will be formed is equal to the volume of cylinder by volume of cone. So volume of cylinder is what? 540 pi. And volume of the one ice cream is 54 pi. Divide them, you get 10. Consider a solid iron pole having a cylindrical portion 110 centimeter high and base diameter as 12 centimeter. This is surmounted by a cone of 9 centimeter height. Find the mass of the pole. Assume that the mass of 1 centimeter cube of iron pole is 8 gram. So you have to consider a solid iron pole having cylinder portion. So there is a cylinder portion having a cylindrical portion 110 centimeter high. So this is 110 centimeter high. The base diameter, so the radius will be, base diameter is 12, so it will be 6. Diameter is 6. Is surmounted by a cone. So here is a cone. This will also have the same radius, that is 6, and the height here is 9. This is the 9. Now find the mass of the pole. So what we will do, we'll take the volume of this cone, we'll take the volume of this cylinder, and we'll just add them. So what is the volume of the cylinder? Pi r square h. So pi, this is r 6 square into h, that is 110. This is h, right? What is the volume of the cone? 1 by 3 pi r square h. So 1 by 3 pi, this radius is also known, 6 square into h, height is also known. So just add them. This one and this one you have to add. When you add this is going to come as the total volume of the iron. And this you compute 127855.14. This is the total volume. Now 1 centimeter cube of iron pole is 8 grams. So this much centimeter cube will be what? Just multiply this with 8 gram. And this will be this gram. And now in order to find out in the kg, just divide it by 1000. You get 102.28 kg. This is the mass of the pole. A solid toy is in the form of a hemisphere surmounted by a right circular cone. Height of the cone is 2 centimeter and the diameter of the base is 4 centimeter. If the right circular cylinder circumscribes the toy, find how much more space it will cover. So there is a solid toy in the form of a hemisphere. It is surmounted by a right circular cone. So here is a hemisphere and this is surmounted by a cone. Hemisphere surmounted by a right circular cone. Height of the cone is, this is 2 centimeter. And the diameter of the base is 4 centimeters, so the radius will be also 2 centimeters. It will be 2. If the right circular cylinder circumscribes the toy, now there is like this. Circumscribe means this is going to touch. Okay, I just made some space because my drawing is not that good, but you just assume that this line is touching here like this. This is circumscribing actually. Now you have to tell how much space it is going to cover. So we just have to find out the volume of this one, volume of the cylinder, and just subtract. So radius is equal for all of them because it is subscribing. Radius of the cone, radius of the hemisphere, and radius of the cylinder. All the three items will have the same radius. It is going to be 4 by 2, that is 2 centimeters. Now what is the height? The height, there are certain things which are given. See, this is 2, and what is the radius? 2. So this is also the radius. So height of the cylinder will be 2 plus 2, that is 4. So height of the cylinder will be 4. And what is the radius? 2. So height of the cylinder will be 4 and the radius will be 2. Okay, this is the radius. Now what is the volume of the cylinder? It will be pi r square h. And as I said, you have to take the volume of the cylinder and subtract the volume of this toy. Toy is volume of cone plus volume of the hemisphere. So volume of cylinder is pi r square h, r is 2 and h is 4. And this is 1 by 3 pi r square h, 1 by 3 pi Again, radius is same for every you can say object. So 1 by 3 pi r square into h. Height is this one, 2. And what will be the volume of this hemisphere? 2 by 3 pi r cube. 2 by 3 pi into 2 cube. So now you just take these values, subtract, and it is going to come as 8 pi centimeter cube. Consider a solid consisting of a right circular cone. Now this is a right circular cone. This is a right circular cone. And the height is 120 centimeter. The radius is given as 60 centimeter. Standing on a hemisphere. This is a hemisphere. Again, the radius is same, 60 centimeter. And this is placed upright in a right circular cylinder. So this is a right circular cylinder. It is placed upright, and this is full of water such that it touches the bottom. Find the volume of the water left in the cylinder. That is, once it comes inside this object, that is cone and hemisphere, the water is, it is full of water. So water will spill out. So there will be some water inside. And what will be that water? We have to take the volume of this one cylinder and subtract the volume of these two. You will get the result. So for the cylinder, first of all, the radius of the base is 60. This is 60. And what is the height? See, this is 120 given in the question. And this is the radius, which is height also of this hemisphere. So this is 60. So 60 plus 120, the height is 180. So radius of the base is 60, the height is 180. What is the volume of the water that the cylinder contains? It will be pi r square h, pi into 60 square into h, pi into 60 square into h. Now, what is the conical part? This conical part, the radius will be 60 and the height is given as 120. So what is the volume? 1 by 3 pi r square h. 1 by 3 pi, that is pi into 60 square into h, 120. Coming to this hemispherical part. The hemispherical part, the radius is 60 and volume of this hemisphere is 2 by 3 pi r cube. R will be 60 cube. So this is the result. Now as I told you that you have to take the volume of the cylinder, then you have to subtract this with the volume of this cone plus volume of this hemisphere. So V1 minus V2 minus V3. So just this is the calculation. It will come as 1.1314 meter cube. Consider a cylindrical vessel with the internal diameter. So we have a cylindrical vessel. So internal means there has to be some external also. So let us say that the internal diameter, this one is diameter is 10 centimeters. So the radius is 5 centimeter. Height is 10.5. So this is 10.5. Height is 10.5 centimeter. This is full of water. A solid cone of base diameter this much and height this much is completely immersed in water. So there is a solid cone here. Find the value of the water when displaced, which is displaced out of the cylinder and left in the cylinder. So when we take the volume of the cone, that is the volume of the water which is spilled out, that is displaced out of the cylinder. Then what we'll do, we'll take the volume of the cylinder and subtract the volume of this cone, that will be the volume which is left in the cylinder. Okay. So what is the cylinder parameters? That is, radius is given as 5, height is 10.5. So we can find out the volume of the cylinder first of all, that is pi r square h. But before that, as I said, that if you take the volume of this cone, this volume of the cone is equal to the water being spilled out. So displaced out of the cylinder is nothing but the volume of the cone. So let us go to the cone first. In this cone, the radius will be 5 and the height, which is the solid cone, 8 and height is 6. So 6 is the height here. So we have the radius also, and the base radius is 8. The base radius is 8. So let me just change it to 7. Okay. So the radius will be 7 by 2. It is going to be 3.5. Radius of the cone will be 3.5. The height is given as 6. So 1 by 3 pi r square h, 1 by 3 pi 22 by 7, 3.5 into 3.5 into 6 square. That is going to be 77 centimeter cube, and this is equal to the water being displaced out of the cylinder. Now, in order to find out the water which is left in the cylinder, we have to take the volume of the cylinder and subtract this volume. So what is, we have to find the volume of the water remaining in the cylinder. So volume of the water left, as I said, volume of cylinder minus the volume of the cone. So pi r square is the volume of the cylinder. R we already know, it is given in the question. This is 5, and height is also known, 10.5. And this 1 by 3 pi r square h we have already found here. 77. So just subtract 77. The result will be 748 centimeter cube. A hemispherical depression. This is a hemispherical depression. This is cut out from one face of the wooden block of the edge 21. So the side is 21, such that the diameter of the hemisphere, this diameter is equal to the side edge, that is 21 centimeter. Determine the volume and total surface area of the remaining block. So what is the volume? Volume is the total volume of this cube. So it is the volume of the cube is length into height, and all these are equal. So x cube. Let us take the side as x cube, and we have to subtract the volume of this one, volume of hemisphere, which is nothing but 2 by 3 pi r cube. And as given in the question, the diameter of the hemisphere is equal to the edge. So this is 21. So it will be diameter, and radius will be 21 by 2, that is 10.5. So x cube, side is 21 cube, 2 by 3 pi r is 10.5 whole cube. The result will be 6835.5 centimeter cube. Now, in order to find out the remaining surface area, so remaining surface area will be, the whole surface area of a cube is always 6x square. So all we have included, but this portion, this top portion, let me show you, it will be like this. So we have to subtract from this 6x square, that is the total surface area of this cube. We have to subtract first of all this portion which is pi r square, radius we already know, 10.5. So 6x square, that is 6 side square, minus this pi r square, this area, pi r square 22 by 7 into 10.5 into 10.5. But there is one more thing. We have to add the depression. So if this is the depression, this area also will come. So we have to add 2 pi r square. This is the 2 pi r square. This portion has been cut, which is what we have deducted, pi r square. But this portion, if you assume this portion will have its own surface area. So this you have to include. But here 2 pi r square minus pi r square is what? Pi r square. So you can easily use the radius of this hemispherical. So 6x square plus pi r square you have to do. The x side is 21 and the radius is 10.5. It will come as 2992.5 centimeter. A boy is playing with a toy which is in the form of this hemisphere surmounted by a right circular cone of the same base radius as that of hemisphere. If the radius of the base of the cone is 21, this radius is 21, and its volume is 2/3. Volume of the cone is 2/3 the volume of the hemisphere. Calculate the height of the cone and surface area of the toy. So here, volume of the cone is 1 by 3 pi r square h. This is 2 by 3rd of volume of the hemisphere. So 1 by 3 pi r square h is equal to 2 by 3rd of the volume of the hemisphere, and volume of the hemisphere is 2 by 3 pi r cube. So if you see here, this r square, because radius both of them has same. So this r square and this r will cut, so only r will come, right? 1 by 3 will cut, so it will be 4 by 3. And 3, this 4 by 3, and we have this height. This height is also given, which is, we are taking the height of what? This part, conical part, right? So what is the height given? Conical part, it is same. So height is not known, so we have to find out. So height will be this 4 by 9 r into 3. As I said, it will be already 2 by 3, 4 by 3 only. So 4 by 3 into r. So h is 4 by 3 into r, and radius is what? It is 21. 4 by 3 into 21, 3 7 is 21, 7 4 is 28. Height will be 28 centimeter. Now, we have to find out the surface area of the toy. What is the surface area? The curved surface area of the cone and curved surface area of the hemisphere. In order to find out the curved surface area, we have to find out the slant height. So this is 21, this is height, which is known to us. Now 28, this we just found out. This is 28 and this is 21, this is 21. So this is 21. So what this slant height will be? It will be 28 square plus 21 square under root. Okay, and this is going to come as 35. So what we will do? Pi into r into L, what we have to do is pi into r into L is the surface area of, or the curved surface area of the cone, plus the surface area of this one is 2 pi r square. What is this? Hemisphere. So pi r plus 2 pi r square. So pi we know, radius also we know, and the L is also known to us, 35, and then 2 pi into r square. What is the radius? Same, 21 square. So we compute this is going to be 5082 centimeters square. Consider a solid which is in the form of a cone. This is a cone which is surmounted on a hemisphere. The radius of each of them is 3.5. So radius of this one, and this one all are 3.5. And the total height of the solid is 9.5. So from here to here it is 9.5. And from here to here it is given as, this is, because this is radius, this will also be radius, this is the height. It is 3.5 from here to here. So what will be this height? 9.5 minus 3.5, so the height will be 6 centimeter. So the height of the cone is 6 centimeter. We have to find the volume of this solid. So volume of this one, that is 1 by 3 pi r square h, plus volume of this one, that is 2 by 3 pi r cube. So the r is 3.5 for here. Height we just found out to be 6. 2 by 3 pi, again radius will be 3.5 whole cube. Just computed, it will be 166.82 centimeter cube. Now there is a wooden cylinder actually, and two part of hemisphere has been cut out. Two part of this portion have been cut out. We have to find out the volume of the wooden toy. So let us assume the radius of the base of the cylinder is r. And what is the radius of the base of the cylinder? It is 3.5. It is already given. And radius of the base is given, and the height is 10. This is 10, right? So what we will do, we'll find out the volume of the cylinder, and minus what we'll do, 2 into, why 2? Because this portion, they are having the same radius, so we can just deduct it, one of them, and just make it twice. So 2 into this volume of this portion is volume of this hemisphere. So what is the volume of cylinder? It is pi r square h. So pi, radius we know, 3.5, and h is 10. Now this is 2 into 2 by 3 pi r cube. 2 into 2 by 3, pi is 22 by 7, and this r is 3.5. So we just compute it. It will be 205.33 centimeter cube. So this is all about this exercise. There are a few more questions in this exercise, but all the questions are exactly like this. So we have covered a lot. So I just leave those questions for you. Till then, thank you so much and take care of yourself.